I'm Zina, one of the educators on this platform. Today I'm going to explain to you how a thermal power plant works by giving you a quick tour. Coal arrival. Have fun and enjoy. Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, and a device called a stacker reclaimer scoops the coal into a conveyor, which transports the coal into the plant, as you can see here. So now the coal is transported back into the plant, where storing and pulverizing takes place. Once the coal is inside the plant, up to a 30-hour supply of coal can be stored in bunkers. The coal moves from the bunkers to feeders to be measured and moved to pulverizers. Each generating unit has 16 coal feeders that supply 8 pulverizers. Coal enters the pulverizers and spins in these large drums, where hundreds of steel balls grind it into a fine powder. Now this fine powder leaves the pulverizers and heads to the boilers. Combustion and steam. Large fans add warm air to the powdery coal and blow it into the boiler, as you can see here. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy into generating intense heat. This changes the water into the tubes to dry, hot steam. This process generates thermal energy, which is transformed to mechanical energy. Turbine generator. High-pressure steam is now piped from the boiler to the first in a series of turbines. Here it expands between layers of turbine blades mounted on the turbine shaft. The steam loops back at the furnace, then on the second turbine. In this process, the steam turns the series of turbines in 36,000 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge, and from here, the electricity leaves the plant and begins its journey to the customers. Water reuse and condenser. After the steam has been used to create electricity, it is exhausted from the turbine and sent to a condenser to be changed back into water. Inside the condenser, steam passes over the outside of pipes filled with cooled water from the cooling towers. The steam condenses to water and returns to the boiler to repeat the steam generating process over again. As the steam condenses, the cool water inside the condenser pipes becomes warm from the heat of the steam. So it is sent to a cooling tower. These towers are called natural draft cooling towers, which are designed with no moving parts. Inside, the water splashes over a series of paddles, which break up the water into small droplets. These droplets mix with air from the open bottom of the tower, evaporating some of the water and cooling the rest. The newly cooled water returns to the condenser to repeat the process of cooling steam again. Scrubbers. This particular plant is equipped with air quality control systems to remove sulfur dioxide and particles called fly ash. Fly ash is removed by a mechanical process, and sulfur dioxide is removed with the chemical reaction using lime. These processes take place in large ductwork scrubber trains located between a unit's boiler and its chimney. Boiler gas passes through scrubbing vessels and are sprayed with slurry, a mixture of water and lime. The sulfur dioxide particles and other pollutants are absorbed by the slurry and fall to the bottom of the vessels. A ran releases the clean gases through the chimney. Transformers outside the plant boost the power so it can travel long distances over transmission lines to where it is needed. Substations located along the path reduce the voltage so it can be moved along distribution lines attached to utility poles. As the electricity nears customers' locations, transformers on poles set down the power for use in homes and businesses.